Hello everyone, welcome to Creative Factory. Today I will be showing you my new project involving UART communication between two STM32 microcontrollers. In this project, the master node initiates communication while the slave node responds to the command, making for an efficient communication setup. Here is the high-level communication system of my system architecture. You can see the master and slave nodes are connected via UART. The communication is fully interrupt driven, allowing for responsive and efficient data exchange. Let's dive deeper into the components. Here I have used two STM32 microcontrollers which are G431KB. The master node is responsible for sending commands and adjusting communication timing, which is very important thing is to maintain the timing, while the slave node processes these commands and provides feedback. The communication between master and slave is handled using UART, a reliable communication protocol. All data exchange happens through interrupt. I opened my library UART handler.h and UART handler.c. I defined Rx buffer size and Tx buffer size to 32. That means 32 bytes. This is bytes. So I want to receive 32 bytes, and I also want to transmit 32 bytes. And you can see I declared the buffer Tx buffer. The size of the buffer is 32 and the receive buffer is also 32. That is my data structure. I want to transmit, that master want to transmit. You can see this fast header, this node ID, this broadcast counter, this feedback counter, command A and command B. So fast header means fast data, and the node ID which is my master node ID I want to transmit, and the broadcast counter I want to count, and this feedback counter is coming from the slave device, that how much feedback slave give I want to count, which is feedback counter, and command A and command B. In your case you can add additional unsigned integer for communicate. Make sure that over 32 bytes. If you want to transmit more than 32 bytes, you can change here. And also you need to change equal this Rx buffer size to Tx buffer size, and this Tx buffer size to this Rx buffer size. And again you can see the data structure for slave data. The data structures I want to receive from my slaves, and these are the feedback I declared here, and I expand the global variable, and these are my function, UART communication init, assign master data, send master data, receive master data. These are my function that I want to assign values to the structure by this function. This starts interrupt for receiving data, and this assigns data to the struct master node data, and this command is used, this function is used for transmitting data via UART channel. In my case project, I also copy the similar data type here, because I want to receive the same data in the slave, and this called master Rx data. I declared this structure as master Rx data. Here the master Tx data, and here this is master Rx data, and this slave Tx data, because this data will be sending by the slave and will receive by the master. That's why slave Tx data. And similarly UART communication init, this initialize the interrupt, and assign slave data, assigns the first data, device ID, temperature, humidity, latitude, longitude and altitude. We can assign here. You can collect the sensor data and assign the slave data here, and that will transmit over the UART, and that will receive the master and send slave data. This function is used to send slave data, and here's the UART type handle type diff. You can, in my case, I am using UART 1 and the slave data type and receive master data. If I want to receive without interrupt, so I need to use this function. So in our case, this communication unit, you can see this send data function. I am using interrupt for sending. Receive master data, I am using interrupt, and this is the callback function. When master sends data and when there is data, this function will be called, and receive the counter, receive data counter, how many data is received. I can count in a global variable and assigns the data. I can share the received data counter by assign here, so master can compare that how many data he broadcast and how many data he receives. So I can calculate the loss of my data. How many data are losing, I can count, and again initiates the receive communication. So here is the overview of you can see I use this GPIO toggle pin to the UART receive callback function. So when the data is received by the slave, the LED will be toggled, and again when the slave will send feedback to the master, the master has the built-in LED that will be also toggled. So you can see the LED is toggling. So this is the RX buffer by the slave, and you can see the similar data I am receiving from my master, and master can assign data by this function. I can assign the value here, and you can see the broadcast counter and feedback counter. I add insert the callback function. When data is received, the feedback to the master. You will notice that the slave responds immediately and continuously. To wrap up, this project successfully established UART communication between two STM32 microcontrollers. Looking ahead, you can plan to implement more complex commands and expand the network to include additional nodes. You can also use differential communication system. You can add this differential communication system by UART. So the next video will be coming with RS485 differential chip. So hit like and subscribe the channel if you like the video, and I will add the project to my GitHub. You can feel free to copy and use in your own project. Thank you very much. If you have any questions,